Hello. In this video, we're going to be talking about geometric sequences. Now, before we get into that, we're going to first review what it means to be an arithmetic sequence. Now, an arithmetic sequence is what we call a sequence, but it's just a list of numbers in which each next term is found by adding the previous term by some common difference. In my example, I have the sequence 2, 5, 8, 11, 14, and so on. And it says here we have a common difference of 3. And we can note that that's true because if we start with the second term 5 and I subtract off 2, the result is the difference 3. If I do 8 minus the term before it 5, the result is 3. If I do 11 minus 8, the result is 3. 14 minus 11, the result is 3. So I would know to get the next term by adding 3 to the previous term. So 14 plus 3 more gets me 17. 17 plus 3 more is 20, and then so on after that. Now a geometric sequence is also a sequence, but this time each next term is found by multiplying the previous term by some common ratio. Here in my example I have 3, 6, 12, 24, 48, and so on. And it's noted that it has a common ratio of 2. And again, we can tell that if I take the second term 6 and I divide by 3, the result is 2. If I take the term after that 12 and divide by its previous term 6, the result is 2. If I do 24 divided by 12, the result is 2. 48 divided by 12, the result is 2. So the ratio here, meaning a fraction that we repeatedly multiply by, is 2. So if I were to go to the next terms, 48 times 2 gets me 96. 96 times 2 is 192, and so on. Okay, let's practice these. So in these examples, we want to determine whether each sequence is arithmetic, geometric, or neither. So first, let's test arithmetic. So what I want to do is I'm going to take each term and I'm going to subtract the previous and see if we come up with some common difference. So my second term is 2. And if I subtract 5 from that, we come up with -3. Now if I take 4/5 minus the previous term 2, well, we're going to come up with some negative number that's not 3. In fact, it's going to be -1 1/5. So this is not arithmetic. All right, let's test geometric. So we want to take each previous term, or each term, and divide by its previous. So if I take 2 and divide it by 5, we end up with 2/5. If I take 4/5 and divide by 2, then we come up with, well, dividing by 2 here is the same as multiplying by 1/2. So I can look at this as 4/5 times 1/2. Half of something is the same as dividing it by 2. And we come up with 4 on top, 10 on bottom, and the result is 2/5. Promising. Let's see if that pattern continues. If we take 8 25ths divided by the previous number 4/5, well, just like 2 negatives make a positive, 2 divides mean a multiply. So we're looking at 8 25ths. We have a divide 5, so that means we multiply 5, but we're dividing the 4, right? It's divide 4, divide 5. So divide means times 5, but still divide the 4. And before I multiply, I can look to cancel anything on top with anything on bottom. Between the 5 and the 25, I can take a 5 out. Between the 8 and the 4, I can take a 4 out. So when I multiply, I get 2/5, 2/5. Cool. And then we'll do the last one here, 6/125 divided by 8/25, which again Really, when we divide fractions, it means we multiply by the reciprocal. The reciprocal of 8 over 25 is 25 over 8. The 25 and the 125, we can take a 25 out of both of them. A buck 25 is 5 quarters. So 125 divided by 25 is 5. We can take an 8 out of both 16 and 8. And so again, we are left with a 2 on top, a 5 on bottom, 2/5. So each of these have a common ratio of 2/5. That means our sequence here is geometric. And the number we repeatedly multiply by is 2/5. So our common ratio, didn't ask for it, but I'm going to tell you anyway, the common ratio here is 2/5. That's what we repeatedly multiplied by. Okay, let's test the next one here. So in number 2, I have the sequence 6, 3.5, 1, negative 1.5, and 4. So let's take each term, subtract by its previous. So I'll start with 3.5, I'll subtract 6, and the result is negative 2.5. Okay, if I take 1 and I subtract 3.5, again, the result, negative 2.5. That's promising. If I take negative 1.5 minus 1 more, indeed it's negative 2.5. If I take negative 4, subtract the negative 1.5, we come up with, well, minus the negative means plus the positive, and so we are looking at, again, negative 2.5. So each of these have the same common difference. So this is an arithmetic sequence. And here the common difference is minus 2.5. We repeatedly subtracted 2.5 from each of them. All right. Let's talk about how we can express these in formulas. A recursive formula gives the first term of the sequence followed by the conditions to get the next term. So in number 3, we have the sequence given to us 27, 36, 48, 64. If I were to check to see if it's arithmetic, 36, take away 27, that's 9. Let's do the next one, 48, take away 36. That's going to be 12. So it's not arithmetic. Let's see if it's geometric. If I take 36, divide 27, I can rewrite it as a fraction here, 36 over 27. I can take a 9 out of both things. We come up with 4/3. If I do 48 divided by 36, here I can take a 12 out of both things. 48 divided by 12, 36 divided by 12 leaves us again with 4/3. Let's try the next one, 64 divided by 48. This time I can take a 16 out of both things. 64 divided by 16 is 4. 48 divided by 16 is 3. Again, it's 4/3. So we have a geometric sequence. We have, so I'll write that down, we are geometric with our common ratio of 4/3. We're repeatedly multiplying by 4/3 to get to the next term. So here's how we would write the recursive formula. We start by listing our first term. So we say a sub 1 equals, and our first term here is 27. A sub 1 equals 27. Now the nth term, a sub n, will be the previous term, a sub n minus 1. So if I'm looking for the 10th term of this, I find the 9th term, and then what do I do with it? I multiply it by 4/3. So again, if I want the 10th term, that means n is 10. So a sub 10 is equal to a sub 9 times 4/3 more. I could do that for any term I wanted. If I wanted the 100th term, I take the 99th term times 4/3. Okay, and that's our answer here. That's how we express this recursively. When we say recursive, that means it refers to itself. And so here it always refers to the previous term to get to the new term. All right, in number 4, we have the sequence 1, 4/3, 5/3, 2, 7/3. Now, one thing we can do here, I'm going to look at 1 instead as 3/3, and 2 is the same as 6/3. 3 divided by 3 is 1, 6 divided by 3 is 2. That'll help me if I want to do the check if I have a common difference. So I can take each term, 4/3, minus its previous 3/3. That first one is 1/3. We have a common denominator already when we're doing our subtraction. So I'm taking 5/3 minus 4/3 next, 1/3 again. How about 6/3 minus 5/3? Indeed, 1/3 again. And then if I do 7/3 minus 6/3, quite right, 1/3 again. So we do have an arithmetic sequence. This one's arithmetic with our common difference of 1/3. We would repeatedly add 1/3. So to do our recursive formula, we first list the first term, which is 1. A sub 1 is 1. And then we find the nth term by taking the previous term, a sub n minus 1. And then we're just adding 1/3 to it, because that's my common difference. And that's how we write our recursive formula for that one. All right, let's look at the explicit version. In the explicit version, we give the nth term of the sequence in terms of n itself. So I have the exact same sequences as before. If you recall, number 5, this was a geometric sequence. We saw it in number 3. Its common ratio was 4/3. So in this, in order to find the nth term, I start with the 0th term, and then I repeatedly multiply that by 4/3, n number of times. So if I wanted to go backwards, the question is 4/3 times what equals 27? 27 is equal to 4/3 times our 0th term, a sub 0. And so to get that alone, I'm going to take both sides times 3/4. We undo the divide 3 with times 3. We undo the times 4 with divide 4. And I do that over here as well, times 3/4. So 27 times 3, that gets us 51. And then we're dividing it by, should be a 4 here, dividing it by 4, so divide 4. 51 is an odd number, so we cannot take a 4 from it. We can't even take a 2 out of both of them. So that's as simple as it gets. So that's our a sub 0, 51 over 4. So our explicit formula for the geometric sequence, a sub n equals our 0th term, 51/4, times, and then we're going to take that number times 4/3, however many times we need to. And when we do repeated multiplication, we show that with an exponent. So if I wanted to find, let's say, the 10th term of this, I would say a sub 10 is equal to 51/4 times 4/3 multiplied on 10 times. And I'm not going to calculate, but that's how we would do that. And we would get our 10th term. Okay, so for a geometric sequence, the geometric sequence formula for an explicit So the explicit formula for geometric is going to follow the pattern a sub n is equal to a sub 0 times our ratio to the nth power. So R stands for our ratio on this. We figured out our ratio, we figured out our 0th term, we plug those in, we have our explicit formula. Okay, in number 6, in order to find the explicit formula, we remember that we had an arithmetic sequence. It's the same as number 4, arithmetic, with a common difference of 1/3. So to find our 0th term, because we're repeatedly adding 1/3 on, the 0th term plus 1/3 should get us the result of 1, which is our first term. We add the 0th term plus 1/3, and we get term number 1. So in order to figure out the 0th term, we're just going to subtract 1/3 on both sides, and we note that our 0th term is 2/3. So our explicit formula here, to find a sub n, we take our 0th term, 2/3, and we add on 1/3 n number of times. Repeated addition is the same as multiplication. So if I wanted to find, let's say, the 5th term, and this one's going to be easy to check here, a little easier than with multiplication. So the 5th term, if I did this right, should be 7/3. So if I wanted to find a sub 5, we would do 2/3 plus 1/3 times 5. Well, 1/3 times 5 is 5/3. And if we add them together, got the common denominator already, we get 7/3. So this formula checks out. Okay, so there is the explicit formula for number 6. Here's the explicit formula for number 5. Okay, that's your crash course on geometric and a review of arithmetic sequences. For now, we are done.